we are going to talk about the third and last part, which is how to move data across the network. Well, uh, there are very important concepts in that part, which we have to talk about. One of them is segmentation. Well, for a source to compose the information into messages, one important concept is what we call segmentation. So this information, for example, a web page or very large video, cannot be sent across the network as one entity. Instead, what we do is that we have to divide this big message into what we call smaller messages or segments. These segments, they they go across the line, and they have to have again certain structure, certain size, and certain header that describes very important aspects about this message. This set of messages will then be um, desegmented by the receiver in order to get the original information. If we assume that there are multiple people that are sending over the network is then virtually shared between these multiple people. In which case, if one person sends a set of segments back to back, he or she will consume the whole resources of that network, leaving no resources for the other person to send anything across the network. So to solve that problem, we have another very important concept, which is what we call multiplexing. Multiplexing is the concept of interleaving these segments from multiple users to facilitate the sharing of a specific medium. As we can see, the segments from this person and the other person will be interleaved, will be sent in a specific order to facilitate the sharing of that medium by two or more people. In which case we will end up with a figure like this, which defines how the messages will be, how the segments will be interleaved between the two users. Of course, in order to facilitate the successful communication in that case, each of these segments have to have a specific identifier that identifies that this is the first segment of my message and this is the first segment of my message. And that's a very important aspect because if one of these segments is lost or it was not delivered successfully, the receiver will be able to identify which segment has been lost, and in which case I can ask the source to send that particular segment again. So, so one important disadvantage about segmentation is that um, some of these segments might be lost, in which case I have to have an overhead of identifying the position of that segment in the original message, in the whole information that I'm trying to send. I have to identify where this message is actually positioned, whether this is a segment number 2, segment number 3, and so on. This will allow the receiver to recover any lost segment, if any. Of course, that's an overhead that I have to add to the message, but I have no other way to facilitate this segmentation and multiplexing. So one important aspect about segmentation is the fact that we have to have this overhead in order to make sure that these segments are delivered in a specific order or they are delivered successfully. So another important concept about moving data across the network, which is what we call data encapsulation. We talked about the encapsulation before, and encapsulation talks about the fact that from one layer to another, the data itself has to be encapsulated into a specific envelope, which will define how this data can be delivered from one layer to another. So while we go down across the different layers, the data will be encapsulated in a specific protocol data unit. We call it a protocol data unit, which defines how this data can be exchanged. So data is encapsulated into what we call a segment or a TCP protocol data unit, which will then be encapsulated in the network layer in what we call a packet or a network protocol data unit, which includes the data, the TCP header, and a network header. This IP packet will be then encapsulated into a frame. A frame is the protocol data unit in the network access layer, which will contain the data and all the headers from the higher layers, and as well the frame header and a frame trailer. One thing we observe here is that for each layer, you add a specific header, which is what we call the envelope of that data, except for the network access layer, which adds both frame header and frame trailer. And we'll talk about the reason for this later on. So the definition of the unit of data in each layer is what we call a protocol data unit. So in the application layer, we talk about the data or the protocol data unit in the application layer. In the transport layer, we talk about segment, which is the transport layer protocol data unit. In the network layer, we have the packet, which is the network layer protocol data unit, and we have the frame in the data link layer, which is the data link layer protocol data unit, and then the physical layer deals with bits in that case. So this is how the encapsulation works. So to compose a web server, to compose an HTML page from a web server, what happens is that the HTML will be composed into an HTML format in a data, which will then be encapsulated in HTTP header, and then in TCP header, and then in IP header. From one header to another, what happens is that we logically go down the stack. So TCP is in the transport layer, IP is in the network layer, and then the Ethernet is in the network access layer. After that, it goes through the physical layer as a stream of bits, and these bits will travel through the medium to the web client. And that's the concept of encapsulation. The reverse operation of this is what we call decapsulation. So when a web client receives the data, it needs to decapsulate, in which case it opens the envelope and gets the protocol data unit in each layer until it eventually receives the actual data, and then it receives the HTML, which will then be displayed on the screen. Okay, another very important aspect regarding moving data across the network is the concept of addressing. So to send a packet across the network, we need to identify where the message should go. Addressing in communication networks is a very complicated issue, in which case we have to have different types of addressing to facilitate the communication across different layers. So we have three types of layers in data networks. So we have the application data itself, and then transport layer uses a specific type of addressing called ports. In the network layer, we use a specific type of addressing called IP address or the network address, and then in the data link layer, we use a specific type of address called physical address. Okay, so the network address, for example, identifies the destination IP address, in which case it defines how the message will move from one source network to another remote network. So the network layer header will define both a source IP address and a destination address. The data link layer defines another type of addressing, which is what we call physical address. The physical address defines how the frame, the data link layer, can move across one network. So again, the physical address facilitates the delivery of a specific frame on the same network, whereas IP facilitates the delivery of the packet from one source network to a remote network. Okay, so to understand how communication is successful in the network, it's important to understand the roles of both the network layer address and the data layer or the data link layer address. So again, as we said, the network layer address defines the source and destination IP addresses, which will then be used by these routers to make sure that the packet is transferred across different networks. Whereas in the data link layer address defines the source and destination physical address, which facilitates the delivery of information across one network. So as we can see, this is one network, and when we move across routers, we move across different networks. So the transmission of frames within a single network uses the data link layer address, whereas the transmission of information across different networks uses what we call the IP address. The physical address is also called MAC address, or medium access control address, for both source and destination. Easy to understand now that in order for us to move data across the networks, we need both the IP address and the physical address. Typically, applications have knowledge about the IP address, but they do not have the physical address of the entity they are trying to communicate with. So for example, if I want to get a specific file from the FTP server, I know the IP of the FTP server, but I don't necessarily know the physical address of that server, in which case I need to know this information. In order for us to get the physical address that corresponds to that IP address, we use a specific protocol called Address Resolution Protocol. So that's the first protocol that we will talk about, which is used to get the physical address that corresponds to a particular IP address. So for example, if PC1 wants to communicate with any of these devices or hosts, it needs to get this physical address. So the first thing it does is that it sends a specific address resolution protocol request to ask the network who has the physical address of that particular IP address. So it sends that query across the network, in which case it uses broadcast to send across the entire network. So if one node has the physical address of that corresponds to that particular IP address, then this device or this host will send back a query reply to indicate that the physical address of that IP address is, and so on. Okay, so what if if the web server that I'm trying to communicate with is across a different network, in which case I have the IP address. Do I need to know the physical address? The answer is no. Again, the physical address is used in the local network only. So, which means that the termination of a network is one of these routers. So in order for me to send the message within the network to reach to the web server, I need to know the physical address of that particular router, or what we call the default gateway. So this PC will realize that the FTP, the web server that it's trying to communicate with, is on a different remote network, in which case It doesn't need to know the physical address of that particular web server, but it needs to know the physical address of the device that's in the same network as PC1, which in that case, what we call the default gateway. And in that case, it sends a message to get the physical address that corresponds to the default gateway IP address. So now, what are the roles of the network layer address or the network addresses? Network addresses, they define the IP addresses, which will then be used by these routers to route um, the information or the packets across the different networks until it reaches to the web server. Okay, so the data link layer address is used within the same network to deliver the message across the devices in the same network. And then the IP address will be used by the routers to route the information across the remote networks all the way to the receiver on the other side. The end of this chapter, and in that chapter we talked about how to establish what are the rules to establish a successful communication, and for that we define set of rules like message format and size, the message timings regarding access methods, the response timeout, and the flow control. And then we talked about protocols and standards, and we talked about the protocols being the set of rules that govern the communication, and standards are internationally approved set of rules that specifies the functionality of a specific protocol. And we talked about protocol suite and protocol model and reference model and the difference between each of these. And then we talked about how to move data across the network, in which case how we use addresses in different layers in order to identify the source and the destination, and how they can be used to facilitate the communication whether on the same network and or a different network. Thank you and see you next time.